ఏమో సార్ లాస్ట్ అయితే angular momentum of electrons is quantized for first shell. You told that, sir.
ఓకే, యాంగులర్ మూమెంట్ ఆఫ్ ఆర్బిటల్ ఇస్ క్వాంటైజ్ వరకు చెప్పుకున్నాం అంతేనా?
Yes, sir.
దట్ మీన్స్ వీ
Yes,
హ్యావ్
sir.
డిస్కస్డ్ ది we have discussed the what we have discussed.
Bohr's theory, sir.
Bohr's theory, only points only we have discussed, right?
Yes, sir.
Now we are going to discuss some certain formulas I will give you, okay, to solve the questions. Then we can go for
Sir,
tell me, Ritvik.
sir, in the previous class I had a doubt.
Ask me.
Sir, in the previous class you wrote that E2 minus E1 is equals to HV, sir, H nu. I didn't
Right.
understand that.
Actually, what I'm saying that if electron jumps from lower level to higher level or higher level to lower level, there will be absorber and emission of energy will takes place, right?
Yes, sir.
I wasted it. Okay, absorption or emission of energy will takes place, no?
Yes, sir.
That energy means what? E equal to h nu only.
Okay, sir.
Okay,
Nu
that
means the frequency, sir.
yes, yes.
Okay, sir.
Okay. Absorbed energy or emitted energy is directly proportional to its frequency.
The energy is calculated in frequency, sir. Shown in.
Hmm.
Okay, sir.
Okay, na?
Yes, sir.
Now, let's say next one, energy of Bohr's theory I'm giving you. Just I'm giving you as a formulas only, na? Okay, na? I'm not going to derive that complete derivations. Just to focus on the formulas, and from their formulas only we can solve the questions. Okay, that is from the Bohr's theory we can define. He had derived that equation also. So energy of nth shell given for hydrogen, like that is En equal to minus 13.6 into Z square by N square electron volts, where Z equal to atomic number. Okay, if formulas away, we can derive these formulas also. He had derived the values also.
Sir,
Uh,
sir, that means are you giving formulas for everything we discussed in the Bohr theory?
yes.
Okay, sir.
Okay.
And you wrote energy spelling also wrong, sir. You wrote only energy.
Okay. Next one, similarly, radius of nth cell for hydrogen. Like I will tell you what is hydrogen like atoms. That is radius Rn equal to 0.529 into n square by z angstrom units. Okay, 0.529 n square by z angstrom units. Okay, na? And from this one, what we can write? So from this one, we can write energy is directly proportional to z square by n square. Okay, na? Okay. Don't write anything, Nana. Just let me write. So from there only, I will write one more point also. For example, చూడమ్మా, in case, for example, if Z equal to 1, that means what? Z equal to 1 means atomic number, it is for hydrogen atom, right? And
Yes, sir.
N equal to 1. N equal to 1 means for the first cell. What we can write? En equal to, so Z value will be 1 and N value will also be 1. No? So En value becomes minus 13.6 electron volts. This is only known as energy of Bohr's first orbit, we can say. The energy of Bohr's first orbit.
Sir,
Energy of Bohr's first orbit, we can say. Okay, Nana? And from this one, what we can write? Energy from above this equation, energy is directly proportional to Z square by N square, we can write. From there, for the same atom, for energy ratio for N1 cell and N2 cell. So E1 means what we can say? N1 means first cell, no? That means what we can write? From there, E1 by E2 equal to what we can write, Nana? N2 square by N1 square. That means E1 by E2 equal to N2 by N1 whole square. Okay. This formula also you have to remember.
Sir, once
sir,
could you
once
move
can you
to
go to
previous slide?
previous slide? Sir, can you explain the last point?
For example, if for the same atom is what, Z value will be same, no?
Yes, sir.
So Z value same and N value I am taking two different cells if I am taking. Then energy ratio value, how we can write?
By, sir. 1/2.
Yes, no. So that all I had written. Two different cells, no? E1 equal to N2 square by N1 I have written. Okay, na?
Sir, these both
Okay.
are energies of different electrons, sir.
Different cells, cell.
This is the ratio of the two shells, sir.
Yes, energy ratio of the two cells.
Sir, here N1 is the first shell, sir.
N1 is first cell and N2 is second cell.
Okay, sir.
Sir, can you go previous?
Done, students?
Done, sir. Sir, done.
Sir,
Okay, can I go for next place?
Yes, sir.
sir, does first shell have more energy or
Yes,
second
sir.
shell, sir?
That I'm trying to do now.
Okay, sir.
Okay.
Sir, done. Done, sir.
See. So from this one, see. So, as somebody asked, let me take in a hydrogen atom only. Mm. So, for first cell, energy value how much? 13.6 by 1 square, right? In the formula, just I'm substituting the values, nothing else. In same hydrogen atom, for second cell, how much it will be? Minus 13.6 by 4, right? That means how much it will be? 3.9 electron volts. Same hydrogen atom for third cell, minus 13.6 upon 3 square, matlab 3 square means 9, right? So the value will be minus how much it is? 1.5 electron volts. Okay. So as we are going like this, for infinite cell, energy will be what?
Minus 13.6 by infinite.
That means will be what? Anything by infinite is 0, right?
Yes, sir.
So this is the value. Now here the questions, two questions are going to come. First question is, of course, energy values are as it is, minus 13.6, minus 3.9, minus 1.9 means energy values are keep on, what is happening? Decreasing or increasing?
Decreasing.
Increasing, no? Minus 13.6 and minus 3.9, which value is more?
Minus 3.9, sir.
Minus
Sorry, sir.
3.9, sir.
That means what we can say, the values are keep on increases and it will reach us to 0. Okay. Now the question
Sir,
is,
can it go more than 0?
Arey yaar, let me finish now. Okay. Now the question is, okay. Uh, First of all, as it will be go more than in 0, it will not. Why? Because according to Bohr's theory, he said around any nucleus there are only infinite number of cells only possible. Okay, so out of the infinite, there are certain cells it will revolve. So if the value is infinite, how it can be 0? More than 0, it will possible, impossible. And second point is, so energy we are expressing in terms of negative values. But energy, will it be in terms of negative?
No, sir.
No, sir.
So why it is?
No.
The reason is, see, so always if I'm taking a nucleus like this, nucleus is there like this, and there will be cells will be there like this. It will keep on up to infinite. It will be there like this. So it is the infinite distance, right? At infinite distance, the electron energy in the cell is 0. But always, what will happen? Electron always try to come nearer to the nucleus, right? Why? Because if it is at infinite dilution, at infinite distance, the nucleus means positive charge. So positive and negative charge should attract each other. If it is going away from the nucleus, then the attraction will be less, right? So for that one, it always try to be in the towards nucleus only. So in such cases, this electron will experience some work to come nearer to the nucleus. So during the process, so it will lose some energy. That's the reason energy of the cell remains always negative charge. Okay, let me explain again. So he is saying that there are infinite number of cells are there. So for the infinite cell, the electron energy in that cell will be 0. But so electron being negative charge, it should be always try to be in attraction with the nucleus. And as we know, how much nearer the positive and negative charges are there, that much what we can say, that much attraction will be there. Whereas to come nearer to the nucleus, the electron will try to experience or they will try to lose some energy. So as the electrons are losing energy, so obviously it will be in terms of negative term or not. So that's the reason energy will be always in terms of negative.
Sir, could you move to the previous slide? I have a doubt. Sir, EV, what's the exact amount in EV, sir? Electron volt, no, sir?
electron volt, 1 electron volt equal to 1.602 into 10 to the power of minus 90 coulombs.
Okay, sir. Sir,
Okay.
sir, and I did not understand the formula, sir.
Which one?
Sir, E1 by E2, that one.
Are where you are focusing here? I had
Sir, no,
given
sir,
no
I
clearly
got to
E
ask
z square by
you.
n square, no? I have taken two different cells. Different cells ratio I
Okay,
have taken.
okay, sir.
Okay. Next one, see. See. Uh, energy of
Sir, once can you go to previous slide?
1 second. Infinite cell is 0 as electron always be close to the nucleus. So electron loses some energy to come nearer to the nucleus. Due to this, energy is in negative terms. Done?
Done, sir.
Yes, sir, done, sir.
Done, sir.
Okay. So this is about the energy term. Okay. And next one, next one, what we can say, radius. Okay. Next one is radius. Okay. That is what we can say. Generally, radius we will represent with r, right? So radius Rn is equal to radius for nth cell of hydrogen like atom. Radius of nth cell for hydrogen like atom. Okay. That is Rn equal to 0.529 into n square by z angstrom units. Okay, 0.529 into n square by z angstrom units. Okay. For the first cell, what we can write? In hydrogen atom.
Sir, radiance means from the nucleus to the shell, sir.
Yes, valency cell distance.
Sir, nucleus means the exact center point of the nucleus.
Yes, center. The hydrogen atom.
Okay, sir.
radius of first orbit. How much value it will be? The n value will, and z is 1. That means it will be 0.529 angstrom units. Okay, it is also called Bohr's radius. Simply we will represent with a naught. Okay. As from this one, what we can write, r n directly proportional to radius of nth cell is directly proportional to n square upon z. Okay. Next one, what we can write, for the same atom, radius ratio of two different cells n1 and n2.
Sir,
Mm.
sir, in the formula RNA, after A there is
Not
equal
a,
to.
it is directly proportional, not directly
Okay,
proportional to.
Sir, could you go to the previous slide? Okay, sir.
Okay. N1 and N2, then what we can write? Then R N1 upon R N2 is equal to what we can write? N1 square upon N2 square. Okay, this is the relation you need to know. Okay.
Can I say n1 by n2 whole square?
Yes, why not?
Sir, can you go on previous?
Make it fast, Nana.
That's so that
Okay. This is what we can say radius. And similarly, one more is there, that is velocity. So velocity of electron in nth shell of hydrogen atom can be given as velocity of electron in hydrogen atom is that is V equal to 2.18 into 10 to the power of 8 into Z by N centimeters per second.
can you go previous slide?
Sir,
Mm.
sir, could you explain the derivations of 0.529, 2.8?
Right now I'm not going to explain the topics, Rana, because you will study in next classes, higher classes you will study. Okay, just let me
Okay.
focus on that problems, how to solve that.
Sir, sir, A naught means It's the radius of hydrogen's first orbit, and we can also call it as constant, sir.
Yes, you can call.
Like Planck's constant, we can call Bohr's radius.
Yes.
Okay, sir.
So done, sir.
Done, Nana?
Yes, sir.
One second, students. So let's solve some problems on this. Okay, na?
Sir, what is it, sir?
2.18 into
No, sir, the symbol nu, is it nu?
V.
Okay, sir.
Sir, what is the units?
Centimeters per second, Nana. Acha, I haven't written, into Z by N centimeters per second. This is V. Okay. Along with that, I will give you some other parts also. Okay. Just try to remember. Okay. This is also somewhere useful in our solving problems.
Sir, can't we make it meters, sir? 2.18 into 10 power 6.
You can convert, Nana.
Okay, sir. I asked you because
Okay.
meters was SI unit, na, sir.
You can convert. It's not a big deal. Okay. Now the question is, so as we know, energy of any particle means what? Whenever we are trying to calculate, it is of what we can say total energy. No, that is total energy of any particle will be equal to kinetic energy plus potential energy, right?
Yes, sir.
So he had calculated the potential energy and kinetic energy also differently. Okay, na? Differently he calculated. So from there, what we can calculate? Okay, from there he calculated where you going to use their ratio also we are going to calculate. Okay, na? So how we were going to calculate, I will tell you. See that. Okay, this is also simple derivation only, but as derivations are not required for you right now, that's the reason I'm not giving it. Therefore, the ratio of total energy and kinetic energy is -1:1. Okay, next one.
Sir,
Sir,
Tell me.
is it -1 or 1, sir?
-1 to 1.
Okay, sir.
sir, kinetic energy is the remaining energy after the loss of work function, no, sir.
Yes, Nana. It will be 1:2. Okay.
Sir, total energy of kinetic ratio of total energy of kinetic
Okay.
energy
Okay.
is
I have written two
-1.
times. It's not like that. It is potential energy.
Sir, up it is -1:1. Sir.
Yes. -1:1 means what? -1. No.
Okay.
Next one. The ratio of kinetic energy to potential energy.
Sir, what is potential energy?
Hmm?
What is potential energy, sir?
And potential energy means what? Electron will do some work, no? After for coming nearer to the nucleus.
Yes, sir.
Okay. That is total energy. From that one, how much electron it is losing? That is kinetic energy, and remaining energy will be potential energy. Simply, potential energy means energy of any particle which is at rest. Okay.
Okay, sir.
Okay, no. This is about the points which you need to remember. Okay. Now everywhere we have written no hydrogen atoms, hydrogen like atoms. Okay. Now I'm going to write hydrogen like atoms means hydrogen like atoms. What we can write? Helium plus Li plus 2, beryllium plus 3. What is the common point in this? Tell me.
Electrons, sir.
Still lose electrons.
So hydrogen means how many electron there? One electron is there. Helium plus also one electron. Li plus 2 also one electron only. Be plus 2 also one electron only. Okay. So that's the reason this theory is completely applicable for okay, completely applicable for completely applicable for what it will applicable.
Hydrogen like species.
So this theory completely applicable for hydrogen and hydrogen like atoms only it is applicable. Okay, na? This is about the hydrogen like and hydrogen atoms, Nana. So now, okay, one more point I'm going to discuss. Tell you, okay. One more point. I think now what's time? 7:40. No. Let's solve 1 2 questions on this. Okay, na?
Sir, hydrogen isotopes also can come under hydrogen like elements.
Hydrogen isotopes, how it will come one electron? One electron systems, no? No, general
Yes, sir.
isotopes we can consider, but
Protons and electrons same system.
yes. Okay, we can consider one electron systems under hydrogen atoms also. Okay, na?
Okay, sir. Like deuterium.
Yes.
Sir,
Mm.
sir, actually till now I got a network issue. Can you explain once again?
No, sorry, Nana, because already I have done. Okay, I'm trying to solve this formulas only I had given. Okay, na? Just try to understand.
Okay.
Okay. Now let me solve certain questions. Question given. Question is calculate the energy associated with the with the first orbit of helium plus. Helium plus. What is the radius of this orbit? Try to solve this.
Sir, I got 0.529 only, sir.
0.
0.529 angstrom, sir.
Let me calculate first. What we need to calculate? Okay, let me find out any answer. Just wait. Let me find out any answers I'm going to get or not. From there we can calculate.
Sir, we are going to get minus 13.6 into 4, na, sir?
Yes.
You do it. So tell me the answer. Then I will
Sir,
tell you.
energy is minus 54.4 EV.
Okay, let's try.
So
Okay.
minus 52 my
So energy means what?
52 10 power 8.
Minus
Minus
54.48.
13.6 into z square by n square, right?
Yes.
Uh, for what cell he is asking first orbit.
Yes, sir. That means square by 1.
First orbit n equal to 1 and
Helium Z.
z value for helium will be how much? 2, no? So En equal to minus 13.6 into z square value will be how much? Z value will be 2 by 1. That is minus 13.6 into 4.
4.
2, 4. Uh, 54.4 electron volts. Okay, na?
Sir, and radius is 0.2645.
Radius formula what? Radius Rn equal to
0.529 into n square by z.
n square by z, right? And z value we know, n value is same, no? Therefore R1 equal to what? 0.529 into n square value how
1
much,
by
Nana? 1 by z value will be 2. That will be 0.2645 angstrom units.
Sir,
Ah,
sir, the main question is how to find the radius, no, sir. We can directly take the formula, no, sir. Rn is equals to 0.5299 to n square by z.
that one I have taken, no?
No, sir, from starting.
For first what he is asking, he straight away asking, Acha, first you want to do radius and after that energy, eh?
No, sir, directly we will get the answer, no, sir. Radius of the orbit. Radius is equals to 0.529 into n square by z. Angstrom
That
unit.
one I did know in the right side part.
Then the left side part, sir.
Left side I calculated energy.
Sir, he's
Because he's
telling
asking radius
directly
and
we
energy
can
also he
do
has asked,
radius.
no?
Okay, sir.
Sir is telling directly we can calculate the radius. Why did you calculate the energy? Is saying.
They asked in the question, sir, calculate the energy.
Arey yaar, he has question, see the question, no? Calculate the energy associated with the first orbit.
Okay, sir.
Yes, sir. Completed.
Done?
Yes, sir.
Sir, 1 minute. Sir,
Hmm.
sir, what is it, sir? Rn or Vn, sir? Is it
Rn,
radius?
Rn. Radius.
Radius of nth shell.
Rn. This is also R1.
Okay, sir. Completed, sir.
Okay. So this is what we will discuss. We have discussed. Okay. So this type of questions, so they can ask you, Nana. So now you can solve this type of questions, right?
Yes, sir.
Yes, sir.
Energy, radius, velocity, straight away formula substitution you can solve, no?
Sir,
You can
what
solve or not?
velocity?
You can solve, Nana, radius, velocity.
Yes, sir.
Yes.
Okay. Next one. So this is for today, and tomorrow we will discuss about hydrogen spectrum. Hydrogen spectrum చెప్పి then we can solve some questions on this. Okay, na?
Okay, sir.
Okay.
Okay, sir. Bye, sir.
Okay, sir.
Thank you, sir. Bye, sir. Good night, sir.
Sir,
Bye, sir. Good night.
Bye,
thank you,
sir.
sir.
Thank
Bye, sir. Good night.